Hello everyone, welcome back. Professor Cameron here. Now, last week in our videos, we covered creating basic outside contours and basic pockets. Now, when we did that, what we did is we sort of tailored our part around the tool we were going to be using. What we're going to do this week is we're going to do a similar process, but this time we're actually going to tailor our tool paths and our tools to the part that we're making, which is a little more realistic scenario. Um, So what we're going to do is we're just going to make this basic piece right here. But we're going to do some things to this that we didn't do last week, specifically with adding different tool paths, different tool diameters. So what we're going to do is we're going to start this like we start every other piece in SolidWorks. We're going to model this basic part right here, and then we'll go through and add the tool paths to it. So we can start this like we start every other part in SolidWorks. And the model for this is going to be really simple. Before we do anything, what we want to do is set our units. We're going to be working in inches for this part. Now we can come over here to our left-hand side, select our top plane, and create a new sketch on our top plane. We're just going to start out by drawing that outside rectangular profile. We're going to come up here, grab our center rectangle tool, put it right at the origin, and drag out a square. And we're going to dimension this to a length of 7.75 and a height of 4.75. And then once we have that, our sketch is defined, we can extrude this. Now we're going to go ahead and extrude this to a height of 2.15. 2.15. And that's going to come back and be important a little bit later on. So we can go ahead and select OK. Once we have that, we can create that rectangular pocket. Now we're going to do the same thing essentially that we did in the last step. We're going to select this top surface here, create a sketch, and we're going to grab our our center rectangle tool. And our dimensions for this are going to be 6.5 by 3.5. Once we have that, it's fully defined. We can cut this to a depth. We're going to go to Features, Extrude Cut, and we're going to cut this to 0.95. And that number is not insignificant. I'll talk about that a little bit later on when we generate our toolpaths, but this is something where we have to, unlike I said before, design our part around the tooling that we have in some instances. So what we can do is we can go ahead and select OK. And there we go. Now, because it's not easy for us to machine with perfectly square corners, we're going to go ahead and put a fillet in here. We're going to grab our fillet tool. We're going to set our fillet radius to 0.13. And then we're just going to fillet these 4 inside corners here. Right like that. We can go ahead and select OK. And that looks pretty good. What we can do is we can go ahead and save this part right now before we continue. So now that we have our part, what we can do is generate the toolpaths, and we're going to start this essentially like we started it last week. We're going to go to our SolidWorks CAM tab, and then just work our way left to right. We're going to start by defining the machine, and we're going to use a mil in inches, and select OK. We are going to set our coordinate system. We are going to do part bounding box vertex. And we're going to select this front right corner. This is where we're going to zero our part in our mill. We're going to set our axes. We're going to set this to x-axis on this front line right here, where it already is. And we're going to set our y-axis to this line right here on the side. And that looks pretty good. Our x positive direction is this way, our y positive direction is this way, and our z positive direction is straight up. And that's how our mill is set up. So that's how we want to set this up. So that looks good. We can go ahead and select OK. Right like that. Next, we're going to go to Stock Manager. Now, last week, what we did is we just chose a piece of stock that was the same size as our part, right? So in this case, it would be 0.75 by 2.15 by 4.75. However, when you go to buy stock, you can only buy it in certain sizes. It doesn't come in every single conceivable stock size. And the value that we're going to address today is this Y value, or the height of our part. In our case, it's Z. And we can alter that by selecting origin here and selecting FCS. This way, we're going based off the origin that we set. So our Z direction is up. Now, a more common stock size for height is 2.25. So what we're going to do is we're going to add 100 thousandths to our Z direction. So what we're going to do is we're going to come to Z here, and we're going to add 0.1, 100 thousandths. What that's going to do is it's going to add a little bit of material to the top of our part. This is going to pose some issues for us, so this is why we're going to do multiple tools. Later on in other videos, we'll add to X and Y values as well and see how we address that. But for now, we're just going to focus on the Z. And there we go. That looks pretty good. What we're going to do now is select Setup, Mill Setup, and we're just going to choose the top surface here. So that way our cutter knows to cut straight down into our piece. That's how we're going to have it oriented. Select OK. We're going to extract machinable features. And what it does is it recognizes this rectangular pocket here as the machinable feature. We're going to generate the operation plan, generate toolpaths. We're going to come back and edit these values in a little bit. And there we go. We have our, in this case, 3 toolpaths. So let's go ahead and simulate this. Let's see how this looks before we go ahead and start editing any of these values. So what it's going to start out with first is a 3/4 inch end mill, and it's just going to come in here and clear out the bulk of this material. And we can fast forward through this. And it's down to the bottom. Now, once it has this material cleared out, you notice it still has a bunch of excess material in here, particularly in around these corners. So what it's going to do afterwards with that same cutter is come in and clear this out just a little bit. But you'll notice, even after that toolpath, there's still quite a bit of material in there. Because that radius is too small, that big 3/4 inch cutter can't fit in there. So what it's going to do is after it clears out those corners, it's going to come back in with a 1/4 inch diameter cutter. And you'll notice that 1/4 inch diameter cutter fits perfectly in that corner. So it's going to clear out that material. But this is going to leave us with another issue, and we'll see that in just a second. So it's going to come through here, and it's going to cut all this material. And look what it's doing right here. See this right here? First glance, you think, oh, this is great. It's doing extra machining for us, right? This in engineering is what we call a bad day, because what's happening is the tool holder that 1/4 inch tool is sitting in is actually contacting this excess material that we have up here, right? Because we had to add 100 thousandths to this, that is actually interfering now with this tool holder. And this is going to essentially ruin our part for us. At the very least, it's going to damage our tooling. So what we're going to do is we'll let this run through. And, it cleaned out our pocket for us, but like I said, it damaged this upside surface. Now, the way we're going to fix this is by actually cutting off this excess material. We have to cut that off anyways. And to do that, we're going to use a face mill. So what we can do is to add in another milling operation, we're going to go to Setup and Mill Setup. Now in our case, we want to mill the face of this, so we're going to select right here for Features, Face, and then we're going to select this top surface, just like we did the first time we did it. And we can select OK. And you can see what it did is it put in a face feature for the top of this part. We can go ahead and extract machinable features and generate operations plan again. Make sure we update this. Generate toolpath. And you'll see what it does is it creates a new toolpath for that face mill feature. So we have our original 3 toolpaths from before, our roughing mill, our contour mill, and then it added in a new mill part setup with a new face mill. And this is good because what it's going to do is, we'll step through this here, run through, mill this all out, just like it did before, and then come through here with a face mill to clean off that 1/1000th of an inch, I'm sorry, 100 thousandths of an inch from before. Now, you'll notice what it's doing is it's putting that face mill operation at the end. Now, we don't want this because from before, we still have that issue where that 1/4 inch face mill or that 1/4 inch end mill is crashing into our part. And like I said, it's going to damage our part, but it's also going to damage our tooling, and we don't want that. So what we're going to do, let's see right here, coming up in just a second. Yep, right here, right? It's still crashing in our setup. So what we're going to do is before we mill this pocket out, we're going to put this face mill operation in. And all we're going to do is just reorder how we have this set up. So to do that, what we're going to do is take our 2 setups here, mill part setup 1 and mill part setup 2. We're just going to drag mill part setup 1 underneath, right? So it should be group 2 and then group 1. Now when we simulate our toolpath, it should come in here with that 2-inch face mill off the top of this, and then after that, it will come in with the, in our case, 3/4 inch cutters. Perfect. And then when we jump to the end here, let's slow this down. Now when we jump to the end here, it's going to cut this, and then when it gets to the bottom, right, that's where it crashed before, there we go. When we look at this, we have just enough clearance room in here for this cutter to cut and also not crash into our workpiece because we faced that off earlier. That's also the reason why we limited the depth of this to 0.95 when we first made this, as opposed to 1 inch or so. because we wanted to leave some room between this tool holder and the top of our piece. So we do have to somewhat design around the tooling that we're going to use. Also, this is a very small diameter tool. You don't want to be drilling or milling super deep holes with a really skinny tool. So it's sort of a balancing act between designing the part you need, but also designing it so that it can be manufactured with the tools that you have. And this looks good, so this is going to run for us. And perfect, we end up with our finished piece, and we end up with our corners cut to that radius that we specified because we use the smaller diameter tooling. And we have our surface, our top of our surface faced off. So now all we have to do is come back in here and edit the values to the appropriate feeds and speeds for our part. So in our case, we're going to start with our 2-inch face mill. So we're going to right click on face mill, edit definition, and here we go. Our tool, it's a 2-inch 5-flute face mill. Now in our case, this is a carbide tool. So that's going to affect our feeds and speeds. When we go to our feeds and speeds tab, we're going to select define by operation. Now, if we recall back from that calculating spindle speed chart, our RPM is 4V over D. We simplify 12V over pi D. So 4 times our surface speed. Now we're using carbide tooling and aluminum, so our surface speed is quite a bit higher, 600 surface feet per minute, divided by the diameter of the tool, which is 2 inches. That's going to give us an RPM of 1200. RPM of 1200. Now our feed rate. Now, theoretically, we can alter this feed rate to match our calculated feed rate, which if we do it comes out to 12 feet per minute. Or we can typically go slower. Generally, the slower you machine, the better your surface finish will come out, specifically with face milling. When I do a lot of face milling, I prefer to do it around the 4 inches per minute mark. I find that gives me a good surface finish in aluminum. But for our case, for our calculations, we're going to go with 12 inches per minute. We can leave our Z feed rate at 5 and our lead-in feed rate at 0.75. These will be fine values for us. For facing, we're going to leave all of this here the same. And then what we're going to do is we're just going to make sure that our first cut amount and max cut amount are set to 50 thousandths of an inch. We don't want to be cutting super deep with a face mill. And then we can go to NC plane and make sure both of these values are top of stock. And then we can click OK. And that looks pretty good. So because this is 100 thousandths thick and our cut depth is 50 thousandths, it should do 2 passes, which we can see from our toolpath here that it's doing. Now we can jump down here to our mill part setup 1 group. And what it's giving us is 2 roughing operations. One for the main body and then one for the corner cleanup. And then the contour milling is where it actually gets in and cuts those corners to the perfect radius. We can actually cut out this second rough mill operation. This one that just comes in and touches up the corners. We can delete that. What we can do is we can edit these 2 values here. So we'll start with rough mill 1. We're going to edit definition. And for this, we're going to go back and use the same high-speed steel tool that we've been using, our 1/2-inch diameter 2-flute end mill. So we're going to go to Tool, we're going to go to Tool Crib, and we're going to select 1/2-inch 2-flute end mill, and select. Yes. For our feeds and speeds, we're going to go to define by operation. And our spindle speed is exactly the same as it was in our last tutorial. It's going to be 2400, and our feed rate is going to be 10. We can go to roughing. For our allowance, we're actually going to leave that 10 thousandths allowance because we're going in with our 1/4 inch end mill, and that's going to clean that up. If we were just doing this in one pass like we did last week, we would set this to 0. For depth parameters, we're going to change both of these here to 50 thousandths, just like we did in our last tutorial. Oops, let's go back into that. To 50 thousandths. We don't want to be cutting more than that, specifically on the machines that we have. For NC, our clearance plane is going to be top of stock for both of these. Now, technically, we could go top of feature here. Because we're already cutting off the top of our stock, the top of our feature is going to be the top of our part, so we don't really have to worry about that. In our case, we're just going to set it to top of stock just to be safe, and then we can go ahead and click OK. And that looks good. And then finally, we can come in here with our contour mill. This is going to be our 1/4 inch end mill. We can edit definition on this. Our tool, it's a 1/4 inch 2 flute end mill, and that's fine. We're going to leave this as is. For feeds and speeds, again, defined by operation. Now, if we recall back from our speed calculations, our spindle speed is a pretty much direct correlation to our diameter. Now, since our diameter is half the size of our 1/2 inch diameter, right, our cutting speed is going to be twice as high. So we're going to go to 4,800 RPM. That's moving quite quick. Our feed rate, we are going to set this to 10. And contour, what we're going to do is we're going to come over here, and just like we did before, we're going to change our first and max cut amounts to 50 thousandths. NC plane, top of stock, and that's it. We're going to click OK. And then what we can do is we can go ahead and generate toolpath again and simulate this, and we'll see how this looks. It should start off with our facing operation and should do 2 passes for this. And that's looking pretty good. That's going to cut our stock down to our final size. And then after it does this, it should come in with the 1/2 inch end mill. And that looks pretty good. I'm going to speed this up here because it's going to take quite a lot of passes with that 1/2 inch end mill. Now, the only reason we're using our 1/2 inch end mill for this is just because this is a common tool that we have in the Wentworth shop. If we had access to 3/4 inch, or in this case, even probably 1 inch diameter cutters, we would definitely use that for time savings. And then it should come in here with our 1/4 inch end mill. And come in and clean out the sides and clean off these corners. And that's all looking pretty good. So let's let this continue. And that's perfect. All right, great. So our tool path for this is done. What we would do is post-process this like we did last week. And if you guys can go ahead and save this model. If you guys have any questions on this process, please let me know. And as always, have a nice day.